The process starts with a feedstock bin, which you can see here. We've supplied it in this instance with a level top, but it can be extended as required. You can see we have sawdust in here at the moment, and the sawdust drops onto what's called a trough conveyor. And in the bottom of this trough, which you can see here, there's a large diameter auger. The auger is a variable speed, which controls the rate of flow to the next stage of the operation, which is our hammer mill, where we then reduce material to a consistent particle size. Material is passed up into a gravity hammer mill, which is this item here. It's a gravity mill as opposed to a cyclonic mill because we don't want any dust at this stage of the operation. Inside the gravity mill, there is a mill screen, which has typically got a 5mm sieve in it, which enables us to produce consistent size sawdust in this instance. Material then drops through the mill into a cross auger, which is in the base of the machine. We're now on the other side of the hammer mill, where we have fitted a binder hopper. In the binder hopper, we are using something called modified cornstarch, which helps to bind the pellets. In the base of the hopper, there's a variable speed screw controlled by the control panel, and that allows us to put a percentage of the binder with the milled sawdust. It then passes through the cross auger in the base of the mill. After the material has left the mill, it then passes into an inclined auger where it transfers to the pellet press. Once the material is passed up the inclined auger, it transfers into what we call a control hopper, which is on top of the press. Okay? In the control hopper, we have a high and low level proximity switch. As the press is running, material passes down through the hopper until the low level switch is activated, and then it starts up the previous processes to refill the hopper. When the hopper is full, the proximity switch at the top then stops the process, so everything prior to the pellet mill starts and stops and starts and stops as required. Material then passes down through the machine into what's called a turbulator. We can then add water or we can add vegetable oil as required to control the compression on the pellet die. That operation is accomplished through peristaltic pumps, which are mounted on the side of the control panel. The peristaltic pumps are variable speed as well, so we control the exact amount of water and vegetable oil we want to add to the mix. Pellets pass across the vibratory sieve onto a variable speed conveyor. Now, the conveyor we're using in this instance is about 6 meters long and it's variable speed. Because the pellets come off the machine at typically 80 to 90 degrees centigrade, they need to cool before they drop into a collection hopper. This particular conveyor, we can control the speed of it from the control panel, and the slower we run it, the longer the pellets stay on it. And so by the time they get to the end, which is about 6 meters away, they're relatively cool enough to go into storage. Cooled pellets drop off the end of the conveyor into a pellet bin and then transfer into a bagging station. As you can see on the left, we have a control panel which operates the plant. It can be operated in manual or auto mode. When we start up in the morning, we'll start on manual mode. We get the plant and equipment up to operating speed, then we can switch to auto. When we're in auto mode, the plant will operate completely unattended. If there's a problem any time, a klaxon will sound which alerts the operator so that he can come and check the mimic. If there's a red light showing, then attention is required in that area. Typically, more sawdust required in the bin.